All right, great. Welcome to the second session of the day, which is an expert panel discussion with Luca Cominardi, Kilton Hopkins, and Frédéric Desbiens. This session would be talking about what is EdgeOps and why should you even care. So DevOps radically transformed the way we build and deliver software. So if you're building cloud-native applications today, you probably leverage a DevOps approach. The rise of edge computing, however, challenges the status quo. Edge computing complements cloud computing by deploying hardware resources and software components in the real world, as close to the source of data as possible. At the edge, a pure DevOps approach is doomed to failure. Why is that? The cloud is homogeneous and centralized. The edge is heterogeneous and distributed. There are nothing alike. So EdgeOps is a vision for the edge computing proposed by the Edge Native Working Group at the Eclipse Foundation. EdgeOps aims to tailor the basic principles of DevOps and an approach which is more suited to the specifications of the edge environment. In this session, you will learn more about what EdgeOps is and why it matters to you from a panel of edge computing veterans. And with me today, I have Luca Cominardi. Luca Cominardi is a senior technologist at ADLINK, working on edge computing and distributed system technologies. He's an active contributor to the Eclipse Edge Native Working Group and committer to Eclipse Zeno. Luca holds degrees in computer science and telematics engineering from University of Brescia in Italy and the University Carlos III of Madrid, Spain. I've also, Kilton Hopkins is the co-founder and CDO of Edgeworx, a startup that provides enterprise-scale edge computing solutions. He's the creator of the Eclipse IO Fog open source edge computing technology. Kilton is a former IoT advisor to the city of San Francisco and recently served as IoT program director for the Level program at Northeastern University. I have also Frédéric Desbiens. Frédéric is the program manager of IoT and edge computing at the Eclipse Foundation, where he helps drive community and open source innovation across different working groups. Previously, he worked as a product manager, solutions architect, and developer for companies as diverse as Pivotal, Cisco, and Oracle. Frédéric holds an MBA in electronic commerce, a bachelor's degree in science, computer science, and a bachelor's degree in education, and all from University of Laval in Quebec, Canada. So welcome, our dear panelists, and we look forward to an interesting discussion with you today.
All right. Thank you, Hassan. And well, thank you to my fellow panelists here. So the conversation will be about EdgeOps, and this is something we collectively wrote about in a white paper that you can download, and we'll elaborate on that. So even if you are not familiar with IoT and Edge, this session is relevant to you in the sense that more and more applications are getting outside of the traditional data center and cloud. So please stay tuned, and you will learn about the specific challenges to that, and probably if you're just a pure cloud native developer, you will still learn a lot. Okay, so well, Hassan already introduced us, so let's jump right in. So Luca, how would you define edge computing? So we had a definition in the session outline, but I'd like to hear about your own personal perspective on this.
Yes, thanks, Frédéric, for the question. So edge computing is quite a wide concept, but I believe that you could track it down to edge computing is what you need for what your application need. So it comes down to, as an outline said, that you need to process your data as close as possible to you, but you could do that for different reasons. You might want to do it, for example, for saving bandwidth on the network to go to the cloud. For example, let's just take an example that you're in a remote location. You've got a very intermittent connection to the cloud, so you might just want to do something more locally to deal with this, or simply because you are transmitting and you need to deal with so much data that you need to send to the cloud that it's better to do some aggregation, for example, on the edge. Or simply, you might also want to do edge computing closer to you to deal with some latency constraints processing. For example, let's imagine that we are adding some image processing coming out from a robot or autonomous vehicle. You would like to do it as close as possible for latency reasons. Or again, you might want to do edge computing to keep your data as local as possible for privacy reasons. So you don't want your data to leave, for example, your protected domain and go somewhere in the cloud, for example, be stored in a non-private or not administratively secure from your point of view location. So this is really in short that depends what you're after. Basically, edge compute can serve different purposes to you.
Okay. And Kilton, what's your take on this? I suppose you agree mostly with what Luca said, but what's your own take?
Oh yeah, I totally agree with what Luca said, and I'll add some to it. With cloud computing, because everything is basically the same, right? It's homogeneous architectures, and the hardware for the most part looks the same. That means that where things run is not so important. There's not really a location aspect, and maybe there is in terms of maybe a region of the cloud because it's closer and you get slightly lower latencies and turnaround times. But the edge is very location specific. It is this end of the building versus this end of the building, this camera versus this camera, and so there's a really heavy location aspect to edge, and by its nature, that means that the places where you put things are heterogeneous versus homogeneous, and so the decisions that you make are driven by things like whether or not there is currently a vehicle within the perimeter of the warehouse that you would like to throw this application into, which is a dynamic location. So there's some addition to what Luca said.
Okay, excellent. And one thing we keep talking about edge computing here, but what's the edge? Where is it exactly? So let's start with you on that one, Kilton, because that could get complicated.
You saw me smile as you asked the question. It's one of my favorite questions. So if you look at the old diagrams from the 90s, in fact, the origin of the term cloud was, here we go from our location, cloud, which means I don't know where, and then it comes out the other side, right? And it was a very telecommunications focused world. The cloud was how you routed information, and you didn't really care which path it took. And at that time, talking about where is the edge was whatever it is that falls outside of that random box that is the cloud. And that carried forward to the point of where a lot of folks still think that the edge is now your private location at which it joins the internet, where your LAN begins. That's not necessarily the edge. What about the edge of the cloud? So we've been doing CDN work for several decades where we push the content into the metropolitan edge of cloud. So is the edge of cloud an edge? It is, depending on who you ask. And so my edge might be a device edge. So that's the edge, is the camera that I'm running on, the vehicle that my software is running in, that's my edge. Everything above that is cloud to me. But it wouldn't be to somebody who's familiar with doing work in the CDN space. And so where is the edge is, I would say, as soon as you have a preference as to the location at which the software runs, that's where edge separates from cloud. And for some people, it's very high up. And for some use cases and some teams, it's very low down to the specific device. And so that's my take on it.
All right. And I would just remind the audience, you can ask questions to our panelists or even react to what they say at any time in the chat or using the Ask a Question feature in Crowdcast. Now, Luca, what's your definition on this? What's the edge and where is it?
So it depends how you look at it, right? So I agree with what Kilton just said. But in addition, I'd like to add another thing, that you might have multiple edges also in your same application or same domain, right? Because it's not something that is on only one location, your edge. For example, Kilton said that you might have your device edge. You might have also some edge that is incorporating the access network of a network operator, for example. You might also have an on-premises data center that you could use at the edge. But this doesn't mean that you need to pick one or the other. So depending on your use case and your application, your requirements, you might have a combination of all of this. You might want to combine a device edge together with a mobile network edge, together, for example, to something that is running on the cloud. Or you just need a device edge, or just a mobile network edge. So that really depends on what are the requirements, what you want to achieve, and then the edge is wherever you want it to be. So you might be able to achieve it to be flexible as possible in order to achieve what you want to achieve. So to me, the edge is a bit everywhere when you get down off the cloud. And let's try to be flexible, not to put things into box, because we are stretching things really out from the cloud down to the device edge. But going from the cloud that is extremely centralized and homogeneous down to the device edge that is the exactly opposite, that is extremely heterogeneous, and where, for example, you've got even embedded devices, constrained device in some cases. You've got a scale of grays, a scale of colors in the middle. So it's a bit up to you according to your application, your needs, to choose how to balance or to balance the right mix for what you need.
Yeah. And certainly this multiplicity of potential edges, depending on your use cases, the topology you choose, the kind of components you have, explains why in the white paper we say that there's this continuum from the edge to the cloud. And really your components can be in any physical location along the way, or even virtual locations in some cases. Now, this brings an interesting question, because we keep saying, edge computing, or even edge native. That's literally the name of our working group at the Eclipse Foundation. So how would you contrast what cloud native is versus what edge native or edge computing would be? So let's start with you on that one, Kilton.
So I think we came up with the term cloud native after realizing that the principles of the scalability and well, I guess I'd say all of the DevOps principles, when we realized that they were being laid on top of older methodologies, we came up with this term cloud native. It's designed from the beginning to be implemented in that fashion, to be fit into that paradigm. And so to be edge native then means to take some of the key principles of edge computing that are different, right? You include all the other stuff, but the stuff that's different is your first principles. And so we've already talked about briefly the heterogeneity of the edge. That's an edge native principle. If you don't handle the heterogeneity of hardware as a first principle in your architecture, then you're not edge native. You're trying to handle edge as an add-on. So if you consider this at the start, it means you would say in your software architecture, in your software infrastructure, in your deployment methodologies, you have awareness of attributes of hardware that are not part of the cloud. Does it have an AI accelerator chip? Does it have a serial port? This is heterogeneity, because not every board has the same peripherals. And being edge native means that those data fields are part of the core of how you deploy, orchestrate, manage, and so on in your edge infrastructure. So if that makes any sense, it's about putting edge stuff first, and then that way it's not a tack-on, add-on thing.
So essentially, we could say that you will use, in the case of edge native applications or edge computing, you will use some tools and some techniques you are used to in the cloud environment. Mm-hmm. But then there's this twist that the whole environment around you is different, even in a physical perspective.
That's right. And so if you want to put it into one, very short description, it's if you take the usual stuff and you feel like, I got to get me some edge, and you add on edge tooling to what you already do, it's unlikely to be suitable at full scale. However, if the tools you choose were designed for the edge from the ground up, they'll look familiar, but they have some additional attributes to them that is very edge specific, as opposed to, just slapping some edge on top of it. Just the same as slapping some cloud or slapping some big data on top of your single instance relational database did not give you big data.
Yeah, some people found that really painfully in the real world, for sure.
Right. Yeah.
All right, so Luca, what's your take on the relationship between edge computing, edge native, and cloud native?
So just continuing to the discussion, right, and just mentioned. So there are things that are different in the cloud. So heterogeneity is not only about the type of processor or the type of machines that you might have, for example, just a smaller server in the edge while you've got a larger server in the cloud. But also have different types of devices that you need to keep in mind that, for example, might be battery powered, or could be, for example, just some sensor that you want to integrate them in your overall system in this case. So when it comes to edge natives, there are things that were designed and were pretty successful in the cloud that works well, but it's really hard to stretch them, to bring them out of the cloud. So, for example, just think about some communication patterns that you have for devices. Well, when you're operating in a cloud, you've got large servers and containers of virtual machine that run on top of it that communicate with each other. Everyone is equal in some sort, right? You might have larger virtual machine or container, but still you are playing on the same ground. When you start integrating things, for example, even microcontrollers devices or things connected over Wi-Fi, for example, at the edge, you cannot expect to have the same exact tool that you're using in the cloud working also in this different environment. So you might want to apply some kind of methodology that you have in cloud natives, also in edge natives, but this requires to keep into consideration more things when doing development on one hand, but also testing on the other hand, because things becomes really difficult at the edge in the sense that you don't have a single pattern or one size fits all for any solution that runs at the edge. In the cloud, you go there, you go to Amazon, to Google, to Microsoft, just to name the three most largest cloud provider, I will say, and you pick from an offer that they provide you, right? It's their possibility, their responsibility to make sure that everything works within their infrastructure. While with the edge, you have things that stretch from really your device to the premises to the mobile network. So you need to have, in edge native perspective, something more when adopting it to be able to develop and test it in an easy way, really all these heterogeneities and all these different domains that you might have your overall system stretching on top of it.
That makes sense. And let's dig a bit deeper there. So we keep saying that there are challenges that are specific to the edge, and both of you already alluded to some of that. But we'll take a more structured way at those edge-specific challenges and try to explore them a bit together. So when I think about this, and we cover those in our famous white paper, so there are several categories. We wrote a few paragraphs about those, so we will structure the conversation around this for this segment. So communications and connectivity are one of the challenges we identify in the paper. So Luca, why is this so important in an edge perspective?
Because I will start saying why it's not important in the cloud perspective. Okay, let me.
Yeah, absolutely. Yes.
Okay, so the cloud is something that is centralized, is up there somewhere. It's basically the only thing that you need to deal with is that you access somehow your cloud, right? It's your responsibility just to deal with that. But once you're in the cloud domain, you're homogeneous internally, right? So the way that you access the cloud is up to you. You might want to do different things, but it doesn't need to be integrated and to interact with each other. In the edge native or at the edge, you start having things co-living in the same location. And the more you go down to the edge, the more you have different communication patterns and connectivity technology. You might have things connected via Bluetooth, Zigbee, LoRa, narrowband IoT, Ethernet cable, fiber optics, and you name it, right? So any access technology might be coexist at the edge, and you might want to use the edge as an aggregation point or exchange point for your data, for example. So that means that on one hand, different connectivity technologies need to be managed, tested, and somehow supported at the edge. And at the same time, you also need to support at the edge different communication patterns. So in the cloud, in the classical cloud, you either push things, data to the cloud, or you get data from the cloud, right? Either you push or you pull it. While in the edge, you might have different patterns that coexist locally, that you might have powerful devices that continuously stream data, some other device that sporadically pull data, some other embedded device that just go to sleep. So is there, but is not there, depending on the time you look at your system, that you want to support that communication that might be more asynchronous, compared, for example, to the cloud, where it's more, let's say, synchronous, that you push to the cloud or you pull to the cloud. And all these things really need to coexist to be harmonized somehow in the edge.
Okay, that makes sense. Now, on your side of things, Kilton, you identify security, safety, and reliability as a very important concern for Edge. So why is that?
So I like to answer this question by answering a obviously it's rhetorical. The audience can't answer, but I like to usually ask a question of the audience. When was the last time you went to check on your cloud application by going to the data center and walking up to the server that was running on and plugging in a USB keyboard and mouse and getting the logs and debugging it that way? Of course, the answer is never. The data centers that we use for the centralized computing, they're locked down so tight. If you've ever visited one, you notice that even the employees have limited access to certain sectors of the building because of the way clientele are split up and so on. Now, enter edge computing. Just walk down the street and look at the sensors that are part of city infrastructure. They're accessible. In some cases, you don't even need a stepladder, and you can get access to the computing resources that are running the edge. So because we have physical access to the devices, they are present in the space for a reason. The camera is doing security analysis in a retail store, so it must be there. There's no version of a camera in a store that can be run in the cloud. Something has to be on premise. And with everything on premise, you now have access that you previously don't have, right? The access that you don't have to cloud computing, you have it for edge computing. If we don't have a security layer that takes this into account, then we're running software in an environment that somebody can, they can clone the copies of the data in the software, they can get in and do additional spoofing. Perhaps they just simply take the device with them and decide to work on it at home and try to crack the keys there. So the security layers need to be aware of the physical on-premise deployment environment that is not the same for cloud. And that's just the base layer, right? Let's start there. Additionally, now you also have concerns around privacy and movement of data. And so being in the physical world means you might be able to capture information that that you wouldn't for a cloud environment, people passing by that are not employees of the organization, and therefore you might need to get a waiver or post something indicating that this data is being processed. And so you have security and privacy go together hand in hand here. But thinking about it first is the concept, right? It's not that it can't be solved, it's that it presents an entirely new set of challenges.
Certainly, and the privacy aspect is especially important as people are increasingly aware of the potential risks of not just the benefits but the risks that it certainly opens on their private lives. And having the right approach to this is especially important when designing a solution. Now, another challenge you identified as important, Luca, as we were preparing this panel, was the integration of diverse technologies as something that's highly important to edge developers. So can you elaborate a bit on this?
Yeah, so I think that you've been mentioning already, Kilton and I, a bit of this heterogeneity that you have at the edge. So when it comes to developing in a cloud native, right, most of your development that you can do it from your laptop or just relying to some tool, right? But with Edge, with this heterogeneity of devices, heterogeneity of virtualization technology that might coexist, virtualization or non-virtualized also environment, you might want to have something running on bare metal on some edge device, for example, or some different CPU architecture. You might have ARM-based, x86, etc. So any type of CPU. You end up that when you start developing something for the edge, you need to take care somehow of all of the heterogeneity. It doesn't mean that the end developer should do it, but you need to have some tool at least that takes care of all this heterogeneity to at least start the development, also to facilitate also then the testing. Because if any edge deployment would require a full-fledged deployment to develop and test it, you can see that this becomes quite tricky for large deployments or specific deployments. You might already in the later stage, perhaps you want to do some on-field testing, but at least at the beginning, you would like to be able to just develop and test your business logic, application logic, regardless of your diverse technology. That you need to take into account, but doesn't mean that they should prevent you or just to hinder your development because of this heterogeneity. So there is the need in the edge for some kind of tool that really helps developers in development, but also some kind of testing for these diverse technologies. You cannot just buy all the boards that you might have. They are available in the market just to see that your software works, right? So, and also, especially also for communication connectivity, that when it comes to different networks, you might want to be able to integrate it without having, for example, a mobile network. Usually you don't have it, right? But you would like to be able to develop, to write your application for that. And then in a later stage, just dealing with, for example, some closer integration.
And it's true you cannot buy all of the boards on the market. And even if you standardize on a specific model and make and that kind of stuff, there will be revisions at some point. It will be discontinued, and the lifetime of the solutions you build at the edge is certainly at a different level than what you find in the cloud, right? You're building this smart building or this connected road. You don't want to change all of the electronic components on the side of that for at least a few years, right, for the whole thing to be profitable. Which brings us to a very important concern that you picked, Kilton, which is management and maintenance. The typical edge project is not like the typical IT project where you will release many versions in a year and things like that. At least now with Devops, that's what's fashionable, right? So there are many specific considerations there in the way that you manage the components and maintain them.
Yes. So let's build off of what Luca said. You've got a proliferation of types of boards that you will never be able to have in your lab, because if you do, buy them all, tomorrow a new one comes out, right? It's unbeatable. You just got an HD TV, tomorrow 4K gets released. What you gonna do, right? So in this environment, and where testing is incredibly important, you have to ask yourself, once something is deployed, how are you going to make sure that you have a perspective on and hold on what is out there, what condition it's in, what's compatible on what board, and so on. Management of these applications is so much more complex than managing an application that could be deployed on new hardware tomorrow if you decided to migrate at no real cost, right? That's one of the benefits of the cloud. You're not going to rip and replace. Chances are pretty good that you put in place hardware that you felt would fit your use case for a decade not because of the cost of the hardware, by the way, because of the cost of the labor. So something to think about if you're watching this panel and you are new to the environment of IoT or edge computing, you might be thinking Raspberry Pi board, Raspberry Pi, what's the small one, the
Pico or the Zero.
Yeah, the Zero. There we go. I'm thinking of the Pi Zero because it runs Linux. A Pi Zero board is $5, $10 US with connectivity, Bluetooth and Wi-Fi. It's okay to change these boards if we need a new one next year. What's the cost of the team member per hour that went and installed that device up on top of a light pole and then set up the connectivity, such as the Wi-Fi, and so on and so forth. Your real cost is in the effort and the time frames to get things changed over. Yes, the cost of hardware is shrinking rapidly. That does not mean that the cost of humans is shrinking at the same rate. And so unless you find some way to automatically just throw them out your window and they deploy, you're going to have a deployment cost. So if you have a deployment cost, then you want to get longer lifetime. And if you want longer lifetime, your management has layers. This is the old one running on the boards that went out a year ago. And these are the cameras that can hold this and this and this. These are the sensors that run this and this version. So if your information flow for application management is basically just roll everything to version 2.1, that's not going to hold. It's going to, and you might have segmentation by customers too. This customer is not ready for an upgrade. Last point I'll make on this is think about CI/CD. Right now, it's for a good reason. It's fashionable and it's an appropriate goal for software teams to be thinking about continuous delivery. So there's a paradigm here that will benefit you, which is, release early, release often, all of these things. And the integration means that you're able to run end-to-end tests before you push something out the door. How do you test a paper cutter actuator that's part of an edge computing solution that's actually on an assembly line? You're certainly not going to waste $500 worth of paper roll to see if it works. Some things are irreversible. In edge computing, things are irreversible because you're taking in data from the real world and you're taking action in the real world. So you have to rethink CI/CD. How do you make sure that the integration appears to be working and some form of certification in a dry run before you push out something new and find that it actually opens the valve all the way on the oil flow and we have downstream damage that's going to cost us millions to repair? I wish we had tested that before we rolled out the new version. That's the type of thing you need to think about in management now versus how it is with cloud.
Indeed, that makes sense. And this is a good segue to our next segment. You talked about CI/CD specifically as one of the things to keep an eye on, but more generally speaking, it's the whole DevOps approach that needs a bit of a tweaking when you think about edge computing, in the sense that it's not that DevOps is not good, but it was born literally in the cloud. And certainly the fact that you bring together the operations and developers, whether in the same team or at least, in the same meetings from time to time, is a good thing, right? We are not arguing about that. But at the same time, if you take the pure DevOps approach, hey, 2:30 p.m., I push a patch and then you create some catastrophe at an airport or on the highway or something, then you immediately realize that you need to tweak things. And this is what EdgeOps is about, in the sense that we came with this, formal or not so formal definition for the right approach. So let's start with this. How would you define EdgeOps as, in the short version, since we have a whole white paper about this, but in let's say a minute or so?
Sure. And that's a question to me, right?
Yeah, absolutely.
Great. So the easy version of it is taking all of the concepts of DevOps that we love and finding how they fit to edge native principles. And so we'll just pick right back up with continuous integration as an example. In our situation at the edge now, continuous integration means being able to verify that the new software packages do in fact reach and run on the edge devices that are part of the solution. Maybe when we're talking about inputs, we can even verify that the inputs are arriving into the software getting processed. But when it comes to certain activities, opening, closing doorways, whatever it might be that we're actuating, that's where we would probably draw the line on integration pass fail. So EdgeOps principle of basically don't do anything that you can't undo prior to saying go, right? Prior to hitting the production deploy button. That principle needs to carry over into how we currently do DevOps. So it's DevOps extended to include edge native principles is what I would define as EdgeOps. And it's very similar to the way that I think it was an Isaac Asimov a set of principles around robotics, right? And one of them basically is to always do no harm in the edge environment, and we have to incorporate that in a deeper line of thinking to DevOps in order to extend it and make it EdgeOps compliant. But that's kind of in a nutshell what it is. And so EdgeOps is going to evolve. It's not, there's, we can't write a blog post today that outlines what you need to do to be compliant with current EdgeOps, modality. It's going to continue to grow. And every month that goes by, we're realizing more and more about edge computing that needs to be included.
All right, that makes sense. So Luca, I suppose you mostly agree what Kilton says, but in any case, what's your personal take on what EdgeOps is?
Yeah, I agree with what's said by Kilton. Just a remark, right? So you always think like in the cloud as a DevOps, the CI/CD operation, or kind of atomic operation, right? Or just a street pipeline where you go, you pass the different stages, and as soon you are good, you get the green light, you're good to go. I mean, while this is pretty nice, this, I think that will change a bit in the edge, in the sense that if you look very, let's say, distributed edges, we got things that, as I said before, could connect and disconnect. You might, for example, be able to do your CI directly on the edge to test if everything is fine with the line that has been drawn by Kilton. But then, for example, the CD might be pretty different. So the continuous delivery to a system that might be very distributed, you might have components of your system that go offline or line, depending, for example, on your status, or they could just go out of coverage. Think about, for example, your Roomba at home, right? That goes to sleep, just wake up, and you wanted to deliver new software there, or your smart camera, for example. It might not be the case that they are always on, depending on the work hours, for example. So all this kind of different dynamics of edge really need to be considered in this EdgeOps, and should also be able to, for the developers and the system integrators, for example, to facilitate the testing of partial system that might be, for example, line offline. Because one thing in the cloud that we are sure, unless some catastrophic event happens, that if you're able to connect to the cloud, you've got the right redundancy at the cloud, right? So everything goes down, you know that you've got your data center network that is redundant. You might have a virtual machine or containers hot, just in a sleep mode, waiting to be plugged in if something goes wrong. But this is not necessarily true at the edge. So all the EdgeOps, so really from the beginning to me, that I will even go one step before hitting CI for me, the jobs, really taking my hands to the developers to be able to support that things in the system might be interconnected, but also something can go wrong, in the sense that you don't have that level of redundancy that you have in the cloud within your system. So all the steps need to consider these aspects in the jobs. That while in the cloud, to me, is more atomic, right? If everything works, you're pretty sure that everything will keep working, unless some catastrophic event happens. But in the edge, you might have not catastrophic events, but just small events that have got the green lining that pass by and unplug your camera.
Yeah,
right?
and in fact, you say something can go wrong. Well, in the case of Edge, something will go wrong, and you have to design in a way around that, depending obviously on what kind of SLAs or what kind of requirements you have at that functional level. Now, in the paper, we identify a number of specific aspects that Edge developers should pay attention to. And our panelists picked their favorite in the list that we are writing about in the paper. So, Kilton, you picked as your number one concern build processors that have to support more processor types. And well, intuitively, you alluded to Raspberry Pis and other types of boards and environments, but let's expand a bit on this.
Yeah, so anyone who is doing container work on multiple architectures is probably already aware of this problem. It's something that I live every day. So I have this this MacBook which I use every day, and I also have a Windows 10 laptop. I guess I'm about to upgrade to 11. And so I mean, it's nothing against Microsoft. Every upgrade is always like that. So both of these are built on x86 CPUs. And although there's cross compilations possible, there's all kinds of ways to create an environment for myself in which I can build for an ARM device. There are times in which the containers that I have built on x86 to run on ARM don't run on ARM the way that I want them to, and I end up needing to have a device with that exact architecture in order to build. And for a lot of people, these are even new concepts. Never even thought about before. Oh, well, I'm accustomed to building the software on my developer laptop or desktop, and then I do my work and it pushes to the cloud, or there's a background build pipeline that runs. I check in my code. It runs from there. And the question of whether it's going to actually operate properly on the end device or the end computer is never brought up. Why would it? So now if I'm a developer and I'm writing software that's intended for the edge, and I hear a more, let's say a more senior person on the team say, well, we've got 3 different architectures that we need to support here. And the one that's ARM32 is a bit finicky. So, make sure you build for that. If I haven't done this before, I'd say, hey, neighbor, do you have an ARM32 board that I can borrow for a minute to try to build on? And also, why is this build taking 4 hours? Because these boards they're not build servers. So the tooling needs to change. We need to incorporate a multi-architecture builds into our processes early so that later we're not stuck saying, oh yeah, the specialty build tool that my team wrote was fine. I move companies and we have none of it. And how do we even get stuff out to the edge? My guess is that the same systems that currently do automated build pipelines and CI/CD will begin to branch out and offer builds on our behalf. But right now, you're going to have to add ARM devices to your build farm. And I promise you, it's not going to be as easy as just checking some boxes. Oh, I want some of these, right? It's not readily available in the cloud.
Yeah, certainly that makes sense. And even if you add, let's say, an M1 Mac, there's no guarantee that if it compiles there, that it will run well on this special ARM232 board that you are running, right? There's no guarantee or there's no uniformity.
Exactly, right. The ARM processors can be quite different in terms of their capabilities, and some of them have instruction sets that are advantageous for a certain use case, and you don't find them on the other ones. That's by design. Whereas x86 is a lot more universal. The power might be greater, but your instructions are likely to execute no matter what. And that's just a generality, but it's mostly true.
Okay, that completely makes sense. And throw something like RISC-V on the top of that, and then you get an increasingly and exponentially more complex.
I didn't even bring it up. I was thinking, do I throw RISC-V into the mix, or is that a little premature? Let's just make it sound as terrible as it is. You're also going to have RISC-V boards in the mix, and so
exactly.
Several different architectures to build for. That's right.
And we've got a question from the audience there that's really well connected to what we just discussed. So we've got I will probably mispronounce it, so my apologies, but we've got Merlin here asking, can WebAssembly improve the situation of supporting specialty architectures? And we discussed that recently in our working group. So Luca, what's your take? Is WebAssembly our big savior? Bytecode is hot once again.
So WebAssembly is getting a lot of attention exactly for this. I will say that it may mitigate the problem, right? You could use it to streamline, say, perhaps huge percentage of common use cases for this. But again, working with WebAssembly, so it doesn't mean that you are able to target all the heterogeneity that you have in the edge, especially for for example, special cameras or special devices, special microcontrollers in the case that you want to integrate in your system. So definitely will help, that there is a lot of work going on there in the community to establish WebAssembly kind of a common agnostic executable, let's say, format for any target platform. But even there, you still have some cases that you need to deal with. So it really depends then on what kind of scenarios you are targeting and what kind of application you are targeting. Because at the end of the day, you might be able to ease your life, but it will not solve all the problems.
And on this one, Kilton, what's your take?
So funny, because on Wednesday, I will be giving a presentation at KubeCon North America specifically to talk about laying down the groundwork at the edge for WebAssembly as opposed to just containers. Luca touched on it already.
Yeah, don't miss that one.
Don't miss that one. Luca touched on it already. Here's the rub. Yes, the bytecode will execute on any WebAssembly runtime across different architectures. How did that runtime get laid down? And if we're talking about edge computing, then it means you're probably, in most use cases, accessing some particular edge sensor, device, or resource. And that means that the interfacing, which is not fully baked yet for WebAssembly, the interfacing with the underlying heterogeneous hardware is your bigger problem. Yes, you can get the runtime out there. How does it talk to the GPIO pins on the board? Now, how about this next board? So the build problem is okay for WebAssembly across CPU architectures, but how about the heterogeneity of the edge? And laying down that groundwork and being dynamic, right, about allowing access to a camera and so on for WebAssembly is a lot of work that's currently going on. It is not solved. If you can help, chip in.
And certainly one of the aspects we also discussed in a recent Edge Native Working Group meeting, a community meeting, was that okay, you can do some of those things with WebAssembly, but the maturity of the various implementations that you have for that, it's fairly mature in the browser, but as a server side or even edge side kind of infrastructure, it's not completely there yet, right? So would you see that as a potential danger for people that are looking at adopting it at the edge?
Oh, I'd say absolutely. If you think that WebAssembly is ready to run on the edge with one-click deployment, it's so far from it. But is it the right thing to focus on? I'd say definitely. There's so many benefits. So it's if you're looking to use WebAssembly at the edge, you're going to have to help build it out first. And so jump in. I mean, WASI
contribute.
WASI is the vehicle for this. It's supposed to be the interface that allows access to the underlying resources into the WebAssembly applications running, but it's a work in progress. So it's not there yet. Don't think you can bank on it. But if you're thinking about where to put effort, join the effort and make it happen. And you probably have first access to some of the latest and greatest amazing stuff of WebAssembly at the edge.
Indeed. So thank you so much, Merlin, for the question. Really a well thought and certainly very relevant one. Now, going back to our list of topics, one of the things that Luca picked, and I see Lou highlighting in our outline the second point instead of the first. So do you want me to ask you about that one, Luca, or?
No,
the first
as
one
you
is
wish.
good? All right. I thought you were sending me a subliminal message at the bottom of my screen. So let's focus on the first one. Well, since one of the dimensions we talked about was CI/CD is much more complex, since you have more target environments, whatever they are, ARM and RISC-V and all of that, and different types of board, and you won't easily find in the market places where you can easily procure those things. So most of the time you need to build those build farms using your own set of boards probably, or things like that. So this means that in a way new testing approaches are needed, isn't it, Luca?
Yeah, definitely. I mean, this application will become more heterogeneous in the edge compared to what you have right now in the classic cloud, right? Where in any case in the cloud you've got kind of a homogeneous somehow environment from the client, from the server. But in the case of the edge, you will need to test more things, I will say, in more, I will say, more possibilities, that things that will go wrong, right? And so you need some more testing approaches and more integrated testing approaches, I would say. Not only new models, but also that more better integration with what you have right now. Because it's a fact that a network is not as stable as you want to be. So you need to be able to test your application according to different network patterns and that network problems, disconnection, node failures, because you might have like one component of the application it is designed to run, for example, on a battery-powered device and it just runs off of battery. So how your application will behave for that. So new approaches for testing that more system level testing, I would say that is needed, especially in the edge, because you will have a very dynamic system, very dynamic infrastructure underneath, and when the developing your application, you like to test it against some of those problems that might occur without doing a specific ad hoc design of your testing with some specific system in mind. You just want to be as flexible as possible to be prepared to any problem that you might have in your system. So network problems, node that just go out of coverage, nodes that they just shut down, or some failures of the component because you don't have the same level of redundancy as of the cloud. So all these kind of things you need to take into account in the edge if you really want to bring to life an edge native application that also takes into consideration more things than just the cloud one. That if I'm the cloud, I'm good. If I'm outside of the cloud, it's not my business because I'm not in the cloud. In the edge, things are more shady from the sense that there is no clear cut on where things will start go right and where things will go wrong, and it's your responsibility. There is really a huge mix of cases that might happen, and some point of time will happen. So just better be prepared for it by integrating really into your CI really at the beginning, all these new testing approaches that you would like to test against them.
Okay, so it seems to me if I'm a cloud native developer entering slowly the world of edge native, EdgeOps is a useful approach. It's a good set of principles to think about, and certainly at the same time you need the proper tools to implement this to support you in building edge native applications. So we just have a few minutes left, and both of you, Kilton and Luca, you are involved in open source projects that implement literally this EdgeOps vision. So let's mention them briefly. So in your case, Kilton, what are the open source projects that developers can use to leverage EdgeOps today?
Yeah, so Eclipse IOFog is the project that I started and continue to work with other amazing people to build out. The concept of Eclipse IOFog is edge application deployment, management, etc. The runtime is flexible. So the thing to think about is we have great runtimes with container runtimes, and we have great runtimes with WebAssembly, and there's, you might even want to use unikernels. But how do you tell the runtime what to do? How do you make sure that it's running in the proper location against secured hardware? How do you understand, thanks for posting the link into the chat there, that's great. How do you understand which version is running where? How do you do upgrades? How do you do rollbacks? How do you ensure that the different pieces of the application can talk to each other, et cetera, et cetera, et cetera? This is edge application deployment, management, and operation. And that's what Eclipse IOFog does. The application, it doesn't really matter. You might be doing AI at the edge, you might be doing IoT sensor aggregation, or you might just be pushing your web server down to the box in your house because you want to use your website locally that you built to show your friends and family. All of these are viable edge computing examples, but how you do it is, that's what IOFog is designed for.
So if it's a container, you can take care of it with IOFog, essentially.
That's right, and integrating going forward, WebAssembly modules, all of this is because the runtime shouldn't matter. And yes, containers come right out of the box. It'll work with all your containers because that's what people use 90% of the time. So
all right.
Yep.
Excellent. How about you, Luca? What are you working on?
Yes. So in my case, it will be Eclipse Zeno. But I'm a committer and one of the main design of Eclipse Zeno. Eclipse Zeno it targets the application actually, right? Kilton said that it helps you with the deployment of your application. Eclipse Zeno really targets when you write your application, what you can use. Zeno allows you to mitigate really, in some sense, also solve all different communication patterns of your data exchange of your application. We said before that the edge is very heterogeneous. You might have constrained devices, that powerful devices connected across different connectivity technologies, and you might have your application components deployed at the device edge, on premises, mobile network, also in the cloud. So when you write your application through Zeno, you're able to abstract all this complexity from the underlying network. So you just publish data, subscribe to data, or trigger, for example, some remote computation in your application, as well as integrated geo-distributed storages to automatic logging and storage of the data of your application. So it really helps you by harmonizing these different data patterns that in the cloud native case are usually shipped by separate projects like the PubSub, remote procedure, and storages. While in Zeno, we merge them all together, harmonize them in an edge native way that we're able to really work in a decentralized manner. So IO can decide to deploy it wherever if it's more suitable for the location, but Zeno will just, inside your application, will do all the magic that you're just receiving your data when you're interested in without dealing on the location of data. So it really provides you location transparency and redundancy also on this edge native environment.
And I think one important characteristic of both projects is that they have this capability in their design to help you, how would I say that, bring a variety of remote deployments together without necessarily having to deploy VPNs or complex network infrastructure. And that's an important consideration because typically edge projects are all over the place in the physical world. So can you, both of you, expand very briefly on this?
Oh yeah, it's and I think Zeno is the perfect way to navigate complex interconnections in a way that actually finally makes sense as a developer. But Luca, I'll let you expand on that a little bit, and I'll talk about the IOFOG side of it. One of the things that you need when laying down edge applications is the ability for the pieces of the application to communicate. In a microservices architecture, which I would argue that even in a WebAssembly world, it's a microservices architecture because we modularize code no matter what the runtime is, no matter what the module is. And in a microservices architecture, you're going to have services such as data storage, like a relational database, available to all the pieces. A middle tier that's probably doing access control and business logic, and a presentation layer, just similar to all these other applications we've always built. But maybe the presentation layer is running in building, and so is the business logic layer, but maybe the database service is running the building next door, and these are on two different LANs. Traditional approach, stitch the LANs together with a VPN or a WAN if you've got the money, right? You get a network set up across the city. You don't want to do that anymore. We don't want to have a network engineer need to come before the EdgeOps a team member to lay down the interconnects so that things can see each other. It's not a on the same network world anymore. It should be application based. And that means it's going to get stood up and taken down dynamically. The connects are going to come when a vehicle enters the facility, the perimeter of this facility, and will join the network. And when it leaves, it will exit it. If it's carrying a VPN so it can stay interconnected, then that delivery vehicle is going to always have access or visibility to the servers and so on. This is the world we want to leave behind. So if I could carry around a picket sign with me everywhere I go right now, it would be no more VPNs.
That makes sense. And then on your side, very briefly, in 30 seconds or so, Luca, how can Zeno help there?
So basically, what the Kilton just said, just using the same example, right? So Zeno allows you to, no matter where you are, you just decide to plug in a new storage. You don't need to bring up a new VPN, and things that are published on specific topics, for example, can be automatically stored or retrieved if you're querying the storages. At the same time, you might decide to replicate your storages in different locations. Everything will be automatically managed by Zeno, as well as, for example, you just want to plug in runtime when everything is already up and running into your Zeno infrastructure, a new computation to do, for example, remote object detection for your camera. You just need to plug it in, and Zeno will do all the magic for routing and deliver the right data in the right moment, the right location, with the right access control for you. So at application level, you just need to care on the data that you're interested in publishing, receiving, computing, or storing, and then Zeno will do the magic for you. You don't need to configure things, VPNs or other things whenever you want to deploy or put in your system a new application or storage
and the
or
special
devices.
sauce there is really the Zeno router, which enables
Yes.
you to establish this. So we are out of time. Thank you so much, to the audience for watching us. Thank you, Kilton and Luca, for participating in this panel. So Kilton, you are the Chief Technology Officer at Edgeworx. Luca, you are Senior Technologist at ADLINK Technology. And in my case, I'm Frédéric Desbiens, Program Manager for IoT and Edge Computing at the Eclipse Foundation. This was our panel on EdgeOps. I hope you enjoyed it. And stay tuned. We have many other interesting sessions throughout the day. So thank you once again, and see you at the next session.